Hello students, today's video is about very important and rather concerned topic from standard number 12, and that belongs to modern physics, which is one of the important chapters to be discussed. From modern physics we will be today confined with atoms, molecules and nuclei, and from that we are confined to hydrogen spectrum. Okay, for hydrogen spectrum I will be giving you a shortcut table that you should remember, and you can crack lot of questions based on that. Okay, but for this you should remember that table and you should practice it a lot. Okay, so let's go for that. So this is the table I am going to discuss with you. So as you might be seeing this 1 2 3 4 5 6 7, there are 7 columns and you have 1 2 3 4 5 6 rows. Okay, each column I am going to discuss with you. First to come is spectral series, then N1 is the first orbit from which the electron is jumping, second is N2, to what last part it is going to jump, then spectral region, what particular electromagnetic spectrum region it belongs to, then the ratio of lambda max to lambda minimum, then what is the lambda minimum value for that and lambda maximum for that. Okay, so let's begin. So first to come is Lyman series, then Balmer series, then Paschen series, then Brackett series, and last to come is P-Fund series. Okay, so as a memory aid to remember this, I like to give you one simple trick that you should remember their initial letters. Like this is L, B, P, B, P. Okay, so it should be remembered L, B, P, B, P. Okay, one more series you have, and that is called Humphrey series, but we do not consider in the physics at least. So L, B, P, B, P, this is how you remember. In order to avoid any confusion, go alphabetically. That BA, there are 2 B's and there are 2 P's. So first BA is dictionary wise coming first, and second BR is dictionary wise coming second. First PA is dictionary wise coming first, and second PF is dictionary wise coming next. This is how you can, as a memory aid, you can remember that. Then for N1, for Lyman series, first line is obtained when it is jumping on 1. Okay, so what important to us is N1. From this N1, where is jump is occurring, that will decide the nature of the series or type of the series. Spectral series 1, this is 2, this is 3, this is 4 and this is 5. Right? For N2, any energy level higher than 1 will be excited state or higher for Lyman series. So guess what these are? 2, 3 and so on up to infinity. It may be 4, 5, 6. Then for this it is 3, 4 and so on up to infinity. Maybe. Then 4, 5, 6 and so on up to infinity. Then for the next you will have 5, 6 and so on up to infinity. And lastly for the P-Fund you have higher 6, 7, 8 and so on up to infinity, which is called limiting member. Then spectral region, it lies in the UV. By UV you mean ultraviolet. Then it lies in visible. Okay, so it lies in the visible, pardon for this writing. Then third Paschen series lies in infrared. This is also infrared and this is also infrared, right? But how to identify that? To identify that, you have to write this. This is a near infrared region, this is mid infrared region, and this is far infrared region. Based on that facts, you can be asked any question, right? Moving on to that lambda max by lambda minimum ratio, which is very crucial in solving that questions or MCQs rather. So I can also discuss the formulas based on that, but in the end of the video. So stay tuned with us. So lambda max by lambda minimum, this is how you remember. You just write this, the ratio kind of arrangement. Then in the numerator you should start with the square of this first number. This is 2. So this is 4. Then square of this is 9. Then this you have 16. Then you have 25. And then you have 36, and in the denominator you should write, you should start with a 3, then next odd number is 5, next odd number is 7, then next one is 9, and finally you have 11. And then lambda minimum wavelength for this is 1 by r, where r is the Rydberg's constant. Then for the next to remember, you should take the 4 which was in the previous column as a numerator. So this is 4 by r. Then you should take 9. This is 9 by r. Are you getting my point? This is how we are remembering. This is then 16 by r. And then finally you have 25 by r. Okay. And now simply multiplying that will give you lambda max. Okay. Because this is very clear, lambda minimum getting cancelled and you will be getting the lambda max. So simply if you multiply this two, you will be getting the lambda max value for the spectral series. So what would be that? It would be 4 by 3r, then this would be 36 by 5r, then that would be 144 by 7r, that would be 400 by 9r, and finally this is 900 by 11r. This is very important table now. Now what are the possible questions that may ask? They may ask direct factual based question. In which region does the Balmer series lie? Clearly it is in the visible. Okay, it is visible to you. Then Paschen series lies in infrared, near infrared. That can be asked which is lying in the near infrared, near or mid infrared or far infrared. That can be factually asked from this table. Or they may ask you what is the value of the lambda minimum for a particular series. Say they ask for the Paschen series. Then for Paschen lambda minimum is 9 by r. Sometimes they ask the ratio of the lambda max to lambda minimum for a particular series. Say for example, they ask lambda minimum by maximum to lambda minimum ratio for say Balmer. Then for Balmer it is 9 by 5. So this is how you can remember. Even though you do not remember or by heart this table, there is a formula for obtaining this. So I'm in the last part of this video, I'm going to discuss that formula, and then by substituting the values of n1, you can easily get that particular ratios. Okay, so let's get into that. Okay, so lambda max by lambda minimum. The formula for this is n plus 1 whole square upon 2n plus 1. You simply keep on putting the value of n1, or better you can write this as n1. So that would make it very clear sense that you simply substitute the values of n1 from the previous table and you will get the value for lambda max and lambda minimum. Hope you will do that. Okay. Then for lambda minimum, what will be the formula? It will be n1 squared upon r, where r is the Rydberg's constant again. And finally, what is the lambda max? Lambda max is equal to n1 into n1 plus 1 whole squared upon 2n1 plus 1 into r. So this is the formula for lambda max. Again, I recommend to put the values of the n1 and just try to find out whether the values we have written in the table are just matching with that or not. Isn't it very simple? So this is how the formula that will help you a lot, right? And finally, sometimes they may also ask number of the transitions or spectral lines emitted. That will I'll also discuss with you. So number of spectral lines emitted, or they may sometimes use another words like number of transitions possible. So I am discussing first of all in general. So in general, this is NE, emitted lines, number, N for number, you may use capital N also. So NE is equal to N2 minus N1 plus 1 in bracket, you have N2 minus N1 upon 2. This is the formula. No matter from what orbit it will jump to what orbit, that doesn't matter, right? And finally, particularly if we substitute N2 as N and N1 as 1, that is first shell, then the number of lines emitted NE would become, say N2 is N, so it is N minus 1 plus 1 makes it 0, so it is, you are left with N, and here N2 is again N minus 1, so N into N minus 1 upon 2. So this is what the formula goes. So hopefully this particular discussion will help you while cracking the question based on hydrogen spectrum. Okay, thank you very much. Have a great day.